So this is pre-calculus 4.4, day 3. We're moving on to where the hypotenuse is not always 1. And so I want to just look at a couple of the definitions of sine and cosine of a specific angle. So we're going to have an angle in standard position. It's going to rotate around theta. And so we have the terminal side of that angle. And on that terminal side, we have this ordered pair xy. And so the radius is the square root of x squared plus y squared. Because we are no longer on the unit circle, we have to consider the hypotenuse when it's something other than 1. And so because of that, then the sine of theta, well, it's normally just y. It is because it's y over a hypotenuse of 1. Now it is actually y over r. And so its reciprocal function cosecant is going to be r over y. So you have to actually consider r is not 1, and you have to include that in the ratio. And cosine of theta similarly is x over r, so its reciprocal secant of theta is r over x. And the tangent isn't affected because it's the same as it's always been. It's y over x, and cotangent of theta is x over y. So it changes right now because the radius isn't 1. When we look at example 1, let negative 3, 4 be a point on the terminal side. Find sine, cosine, and tangent. Well, you can do this. We've got theta. This is your theta prime. But you need to find r. And it's the square root. It is the square root of a negative 3 squared plus 4 squared. Because this length, well, it's negative 3, but the length is actually 3. This is up at 4. And it's going to be a 3, 4, 5 triangle. But it's good to remember x is negative. And also remember, all students take calculus. All students take calculus. All trig functions are positive in quadrant 1. Sine and its reciprocal, which is going to be cosecant, are going to be positive. The other 4 are negative in quadrant 2. Tangent and its reciprocal, cotangent, are going to be positive in quadrant 3. The other 4 are negative. And cosine and secant of theta are what's positive in quadrant 4. The other 4 are negative. Now, as long as you are using, in this case, x is negative 3, y is 4, and the hypotenuse is always considered to be positive, your signage is going to come out right. It's going to come out correct. And so the sine, and you need the argument of theta, very particular about that. You need the equal sign. Sine is opposite over hypotenuse. It is y over r. It is 4/5. The cosine of theta is adjacent over hypotenuse. So this is your adjacent. This is your hypotenuse. It is your x over r. It is your negative 3 over 5. And make sure that the negative sign's in there. And the tangent of theta is y over x. And so it is going to be 4 over a negative 3. But we don't leave the negative in the denominator. Put it out in front of the fraction and make sure that it's not mixed up with the equal sign and that it's clear there. So once you set up the triangle, you can use this triangle, but make sure that you leave the signage on the x that it's negative so that you don't lose that cosine is adjacent, that comes out negative. But you can use your SOHCAHTOA definitions on that triangle as long as you treat this as a negative 3. But these are always true. When is it important to use this? When the hypotenuse is not 1. All right. Now, determine the quadrant in which theta lies. And this is just a fancy way of saying sine is negative. And sine is positive in quadrants 1 and 2. So that means sine is positive, so those are eliminated because sine is positive in quadrants 1 and 2, and they're telling you sine is negative. It's just a fancy way of saying sine's negative. Sine, it's the y-ny sign. Y is negative in quadrants 3 and 4. So 3 and 4 are possibilities. But then they go on to tell you that cosine is negative. And cosine deals with x. Cosine is positive. Oops, I wanted to change colors there. Cosine's positive in quadrants 1 and in quadrant 4. All students take calculus. Cosine is positive in quadrant 4. The other 4 are negative. So we eliminate 1 and 4 because of the cosine being negative, and therefore the only thing that's left is quadrant 3. So what angle does it lie in? Quadrant 3. So similarly, secant is positive. Secant is, yes?
If I don't use Roman numerals for the quadrant number?
You need to use Roman numerals for the quadrant number. I don't mind you asking. Yep. All right, so for secant, secant is the reciprocal of cosine. So secant has the same signage. It's positive and negative in the same quadrants that cosine is. And cosine is positive in quadrants 1 and 3 because that's where x is positive. And so cosine would be negative in 2 and 3, so you eliminate 2 and 3. So it's got to be either quadrant 1 or quadrant 4. And cotangent is negative. Cotangent deals with both x and y. And so cotangent is going to end up being negative in quadrant 2 because x is negative, y is positive. You get one of each. And in quadrant 4, cotangent is going to be negative. Because x is positive, y is negative. You get one positive, one negative in those quadrants. So it's those two. And cotangent is positive in quadrants 1 and 3. So we eliminate 1 and 3 because that's where cotangent is positive, and you're left with quadrant 4. So your answer to this has to be quadrant 4. Has to be quadrant 4. All right, so in example 3, this previous example leads us to example 3 because cosecant of theta equaling 4 is telling me that cosecant is positive. And so these two pieces of information are going to drive me to which quadrant I am landing in. The cosecant being 4 is saying it is positive. Cosecant's the reciprocal of sine, and sine is positive in 1 and 2. And so therefore, we can eliminate 3 and 4. And then cotangent is negative. Cotangent is negative, we just talked about it, in these two quadrants. So you can eliminate 1 and 3. That's where cotangent is positive. They're all positive in quadrant 1. And cotangent, tangent are positive in quadrant 3. So where do we have to end up? It's got to be a quadrant 2 angle. X is negative, Y is positive, and R is always positive. So for my angle in standard position, I'm going to rotate around, and I'm not really worried about where I end up. I mean, I'm going to just create a triangle. This is my terminal side. As I rotate, drop a perpendicular always to the x-axis, never to the y. And this cosecant of theta being 4, you need to think of it as 4 over 1. You need to think of it as 4 over 1. And then you need to know the definition of cosecant. It's the reciprocal of sine. It is r over y. It is your hypotenuse over your y value. And so I can put on the triangle, this is 4 and my y value is 1. This is my theta prime. Can you calculate x? Now, I will tell you this, I get people all the time taking 1 squared plus 4 squared and taking the square root of it to get x. No, you got to think about 4 is the hypotenuse, not a leg. And so to find x, I've got 1 squared plus x squared equals 4 squared. And you get 16 minus 1, and the square root of that is 15. And we're going to treat it as negative simply because we know that we are in quadrant 2 and x is negative there. Negative square root of 15. And you get plus or minus.
Okay.
But that's why the quadrant's important. Because we're in quadrant 2, we have to take the negative. That's why you need to figure out what quadrant you end up in. And now you should be able to get the other 6 trig functions. And as soon as I know cosecant is 4, its reciprocal is sine. And sine is going to be 1/4. And also, you're working with this, and it's opposite over hypotenuse. And then we've got cosine of theta is x over r. It is a negative root 15 over 4. It's x over r. And its reciprocal is secant. So it will be negative. It's 4 over root 15, but we never leave it like that. You always rationalize the denominator. I really want to make sure that your negative sign is not mixed up with your equals or your fraction bar, that it's very clear that it's there, because I won't accept it if it's not clear. And then you just have tangent. I mean, if you figure out what quadrant you're in, and if you set up the triangle, you can use your SOHCAHTOA definitions to do that. But it is very handy to know the, r over x, r over y, the x over y. It's just handy to know those definitions. And so tangent doesn't change from when we're on the unit circle to here. Tangent is your y over your x. So it's y over a negative root 15. So it's a negative root 15. Or 15. And cotangent of theta is, I would be thinking about this. The reciprocal of that puts the negative root 15 in the numerator. Cotangent is x over y, and that's just going to end up being negative square root of 15. Are there any questions so far? Now, you have to get a strong sense of, am I on a unit circle where the hypotenuse is 1, or does this change it up where the hypotenuse is not 1? You have to be in the driving seat of that when you make your decisions. You've got to recognize when the problems change it up. So think about that as you do your homework. Okay, so page 2, backside. So find the exact, draw the triangle in the coordinate plane and find the exact value. So they're giving you an ordered pair. And in this first one, you've got, it's positive, positive. That tells you what quadrant you should draw your angle in. And it means you've got a quadrant 1 angle. So if I have an angle in standard position, and just rotate its theta, decide where it stops, draw a right triangle, and the x is √7 and the y is 3. So it's the same kind of problem that we had in example 1, but they just gave you the information differently, where you have to put the ordered pair on the terminal side. And you need to understand that the hypotenuse here is not 1. R is the square root of √7 squared plus 3 squared. It's none of those, √2/2, comma √2/2 kind of ordered pairs. It's not a √3/2, comma 1/2 ordered pair. It's not a 0, 1 or -1, 0. It isn't those ordered pairs that we find on the unit circle. So you get 7 plus 9. That was kind of nice. And the hypotenuse is always treated as positive. The hypotenuse is always treated as positive. And now they just want cotangent. And cotangent is adjacent over opposite. It is x over y, which I guess we wouldn't have. It said draw the triangle in the coordinate plane. So you needed to draw it. But since cotangent just works with x and y, we actually wouldn't have necessarily needed the r. But that's okay.
What does R stand for?
Radius. So the radius. So you're just, instead of having on a unit circle where you're at 1, right? Now your radius is way up. Okay, I can't scale it because I didn't do my, your radius is at 4. You're just on a larger circle. Good question. All right. All right, so tangent, it's negative, negative. It is going to be in quadrant 3. So you draw an angle, it rotates around somewhere, and we have negative square root of 15. I'm not worrying about it being accurate. If I did, I guess square root of 15 is going to be a lot bigger than -2. So I maybe could have, I didn't want that to happen. Rotate it around more like this. It says draw the triangle, so we need the triangle. So this is negative square root of 15. This is -2. And technically, do we need the radius? Does tangent, in the definition of tangent, involve radius at all? No, so technically we don't really need it. Tangent is y over x. So, and tangent is all students take calculus. Tangent's the one that's positive, and it works out because it's y over x, and that's going to be a positive 2 √15 over 15. All right. So remember how I said yesterday's assignment is imperative, that when they give you tangent of pi thirds, sine of 11 pi 6, it's imperative that you have a method that will get you the right answer to that. Yes? Okay. Because now we're going in reverse. They are giving you the result, and they want you to match it with the angle. So you've got to do this in reverse. Find 2 solutions. Give your answers in degrees and radians. Don't use a calculator. This is where cosine on the unit circle is your x value. And you should know that your reference, that your reference angle That's supposed to say reference angle. And the reference angle, when you're getting an output of root 2 over 2, it is 45 degrees or pi 4. Does that make sense to you? Yes? No? So your reference angle is 45. The root 2 over 2, it should be kind of like a, yay, this is the easy one. And then you need to decide in what two quadrants is cosine going to be positive. And it is, where is x positive? X is positive in 1 and 4. So we're talking about this angle here where you get a root 2 over 2, root 2 over 2, and therefore the x value is positive. And then we're talking about where you have a 45 degree reference angle where you've got root 2 over 2 and negative root 2 over 2. And x is positive there. So what are those two angles? So what is the angle as we rotate to here? It is pi fourths in radians. Or I'm going to say theta is, and you better put the degree symbol on the degree. And then what is the angle as I rotate all the way to here? It's 1 pi fourth short. In the quadrants, you get the odd multiples of pi. A 1 pi fourth, a 3 pi fourths, a 5 pi fourths. So the fourth quadrant is 7 pi fourths. 315 degrees. 45 degrees short. Those are your solutions. So then where is cosine negative root 2 over 2? Well, there's still 45 degree reference angles, but you're going to be where x is negative, so you're rotating to a 45 degree reference angle in quadrant 2, and so therefore theta is 3 pi fourths. Or you're rotating all the way around to quadrant 3, and that's where it is. It's the odd multiples of pi fourths for the reference angle. And the degrees that correspond with those, 135 degrees, and 45 beyond 180 is 225 degrees. I kind of jumped into that. Can I get a thumb sideways, a thumbs up or down? You can just in front of you. Yes, you think you've got that, please? I just kind of need to see where people are at on this. Okay, so what can help you is practicing the unit circle and knowing all the degrees as you go around. Just being able to take that second quadrant and go, there's 120 degrees. 15 beyond that is 135. 15 beyond that is 150 degrees in terms of radians. This is two sets of pi thirds, odd multiples of pi fourths, and you're 1 pi sixth short of half a turn. So you just need to be able to know those values and pick them up quickly. That will help you on that. All right, so on the next one, I immediately am going, this is something to do with the 30, 60, 90. I'm immediately, when I see the 2 and the root 3, I'm like, this has got to do something with a 30, 60. So it's either a 30 degree reference angle or it's a 60 degree reference angle. Because the 45, 45 are either 1 or root 2 over 2 or root 2. They're just, the 45 deal with 1s and root 2s. the 30, 60, 90s have the 1/2 and introduce that root 3 over 2 in there. And what I think is helpful for me is this is rationalized. What is it? What was it before you rationalized? 2 over rad 3. And what is the reciprocal function for cosecant? What is the not the value, but what function is the reciprocal cosecant? So cosecant starts with the C, its reciprocal starts with an S. The reciprocal is sine. And so then flip it, right? Right? Then flip it, and the sine of theta is root 3 over 2. So I'm looking at places where the whiny sine, I'm looking at places where y is root 3 over 2. And that's the long leg. This is a 60-degree reference angle. Where are you at on doing this? Sine is positive in quadrants 1 and 2. If this is root 3 over 2, I'm looking for where is the y coordinate root 3 over 2, and that means I am going up the value of the long leg and that the short leg must be 1/2. In quadrant 2, if I rotate all the way to there, the y coordinate is my root 3 over 2. And my x is negative 1/2. I'm looking for for what angle is the y going to be root 3 over 2? And that is pi thirds and 2 pi thirds. It's where you divide it into, you have 60-degree reference angles. And that's in radians, and in degrees, that's 60 degrees, and double that, 120 degrees. That means you need to know those values in what quadrants for signage, and so you can pull those out backwards. And this is that next level that is as imperative as what I talked about was on yesterday's homework assignment. This is super important, super important. I do want I just want to mention one other kind of problem. I'll leave that up because I can see some of you are working on it. What if I asked you where, or had you evaluate the secant of a negative pi? Without a calculator, do you have your process down? This is not one that is a 30, 60, 90 because it lands on, if you draw this, right, you're rotating backwards to here at negative pi. You're ending here. So if I go to the unit circle, this is to the left 1 and up 0. And secant is the reciprocal, it starts with an S, it's the reciprocal of cosine, so it's the reciprocal of the x value, and the reciprocal of negative 1 is negative 1. So just FYI. Okay, your assignment for tonight is a worksheet. So